Hi everyone, it's Tara. Welcome to the channel. I have just started going through the new DevSecOps learning path on TryHackMe. I'm so excited about it. If you watch my other video where I kind of went over like an overview of the learning path, you might have noticed I was really on one because I'm just so excited about this learning path and I think the rooms are going to be really fun. In this video, I walk through the second room on the learning path, which is about it's an intro to the software development lifecycle, SDLC. And these first like introduction rooms in the module are really just more, it's a lot of reading, a lot of background information, a lot of context. So we haven't gotten too much the hands-on stuff yet, but in this video, we define what SDLC is, go through the different phases of the software development lifecycle, talk a little bit about how DevOps comes into play. And then there is one like little fun hands-on exercise at the end where you practice allocating resources to different phases of the software development lifecycle. So all that to say, this is my walkthrough of the SDLC room in TryHackMe, and I hope you enjoy the video. Here we have my dashboard in TryHackMe. I'm very excited to announce I finally cracked the top 200,000, so that's exciting. And the next room in the DevSecOps learning path is a room about the software development lifecycle. So let's just go ahead and jump into this next room. This room is called SDLC, an introduction to the software development lifecycle. This is another free room. So if you don't have a TryHackMe subscription, you could still go to this room and follow along if you'd like, and I'll make sure to put a link in the video description. This room focuses on the software development lifecycle, SDLC framework, its phases, and its components. We're going to learn about SDLC framework, what it is, why it matters, learn about the different phases in the SDLC, learn how to instill security into the SDLC, and then understand the security SDLC phases and processes. And I noticed the next room after this is about secure SDLC, so kind of be interesting to see how these two different rooms are structured. But with that, we will hit complete for the intro and jump into task 2. All right. I just saw something that makes me think we're sticking with our little Star Wars theme in this room, so that'll be fun. Task 2, SDLC. What is software development lifecycle? The software development lifecycle is a set of practices that make up a framework to standardize building software applications. So if you didn't guess by the name, it's about software development. SDLC defines the tasks to perform at each software development stage. This methodology aims to improve the quality of the software and the development process to exceed customer expectations and meet deadlines and cost estimates. So it's just basically supposed to make everything better. And for example, with customer demand, computing power increases, which raises software costs and developer dependence. SDLC provides a way to measure and improve the development process by providing insights and analyzing each stage, maximizing efficiency and reducing costs. So having the different stages helps measure and improve development process overall to make improvements and solve problems. How does SDLC work? And remember, we can click here and see a little definition of SDLC if we want of the different terms. The software development lifecycle provides the guidance required to create a software application. It does this by splitting these tasks into phases that form the software development lifecycle. Standardizing the tasks within each phase increases the efficiency of the development process. Each phase divides into granular tasks that can be measured and tracked. So the smaller we can break things up, the better we can measure and track them, I think is the idea here. This introduces the capability of monitoring to ensure projects stay on track. The aim of SDLC is to establish repeatable processes and predictable outcomes from which future projects can benefit. SDLC phases are usually divided into 6 to 8 phases. And the phases are, like I said, we're rocking the Star Wars theme again: planning, defining requirements, designing and prototyping, software development, testing, deployment, and then operations and maintenance after the software is deployed. And I don't know if anyone watching would agree with this, but I always feel like one of the underrated, hardest parts of software development is this one right here, the defining requirements stage. I feel like when you work with people who are really, really good at this, especially if you're working with customers and external stakeholders, people on the team who are really good at getting defined requirements, that's like such a superpower, in my opinion. All right, so here's a description of each of these phases. Planning. The planning phase encompasses all aspects of project and product management. This includes resource allocation, project scheduling, cost estimation, etc. Requirements definition is part of the planning to determine what the application is supposed to do and its requirements. For example, a social media application would require the ability to connect with a friend. And like I said, this one, if you get this one right, it makes everything else so much easier. And sometimes your stakeholders might not even really understand the requirements yet themselves, and that's something you have to navigate. So getting defined requirements is really important. Design and prototyping. So that establishes how the software application will actually work, what kind of programming language and tech stack you're going to use, how methods for the components to communicate with each other, the architecture you're going to use for the application. For example, in this phase, you would decide, oh, maybe we're going to use a serverless architecture, or maybe we're going to use these type of servers and this type of configuration. That's the design phase. Software development entails actually building the program, writing the code, and then documenting the program as you're building it. Testing, that's pretty obvious. In that part, you test it. So you ensure different components work and can interact with each other, and each function works correctly. Different parts of the application work seamlessly together, and performance-wise, there's no lags in processing, etc. Deployment, in this stage, the application or project is actually made available to the users in production. And operations and maintenance, this is where engineers respond to issues in the application or bugs and flaws reported by users and sometimes plan additional features in future releases. Nobody will be a better tester than your actual end user. And companies can choose to rearrange by splitting or unifying these into 6 to 8 phases. So that was 7 on the list we went over. For example, we could merge the testing phase with the development phase in scenarios where security is introduced into every development step as developers fix bugs during testing. It can depend on the software development model. Software development has evolved, as we saw in the intro to DevSecOps room, and the different SDLC models include Waterfall, Agile, and DevOps, which are the ones we learned about and saw in the previous room, amongst other models. All right, and then the question here is, how many phases can an SDLC have? And I think they just told us the answer to that was 6 to 8. So let's see if that's right. And the diagram we saw had 7. So sometimes it's not exactly like this. The phases can be combined or parsed apart even farther. It depends, I suppose. And then let's see. Task 3 is called SDLC phases, part 1. All right, we got some more reading here. The first phases focus on breaking down the project or application before moving on to the development of the application. It seems like this section focuses on the phases that happen prior to actually coding the application. So first, you do the planning, and the planning phase can also be known as the feasibility stage, where you're going to figure out, is this even possible? The feasibility, could we even actually build this? Is it possible? Are there limitations in place that would block this from actually happening? And I have to comment here, I have definitely been in situations before on software development projects where the feasibility stage did not happen right at the beginning like it should have, and feasibility analysis was not as well considered during planning as it should have been, and it causes a lot of heartache and problems down the road. So I definitely think thinking of the planning stage as a feasibility stage is a really good mindset. You don't want to be realizing something isn't possible or isn't feasible when you're all the way down here actually already writing the code. But no matter how good you are, I do think that probably happens sometimes to everyone, regardless. The scope and purpose of the application are determined. That's part of the planning. Software development is planned and implemented. Additionally, the planning phase helps to keep the project focused on its original purpose while setting boundaries. Here, the system's problem and scope are defined, and I think that means the system of what you're developing. And the requirements for its upcoming design can be determined. The process of devising an effective outline for the forthcoming development cycle should enable issues to be caught before they have a detrimental effect on the process and help them identify the resources they need to make their plan happen. The planning stage can be crucial if the goal is to have a product ready for market by a specific date. So start with a good plan. Hopefully you can be on track to your goal. Next is requirements definition. A system's requirements stage involves defining the prototype ideas and gathering all the necessary details. This may be in the form of making a list of all the requirements for a prototype system, prototypes being evaluated against alternatives, other possibilities, identifying the end user's needs through research and analysis. And I don't know if we're going to see it here, but you always hear the phrase user stories a lot when you're talking about requirements. And that would be As an end user, I can create an account. As an end user, I can add a friend. As an end user, I can add items to my cart. As an end user, I can check out. All those kind of things. And when you're requirements gathering, you're figuring out what are the specific requirements that this product needs for the end user to be able to use it. That's one thing. The end user using the product is part of it. And then requirements gathering is also about like what kind of traffic does this system need to be able to handle? What kind of scalability do we need? Where in the world do we need infrastructure deployed? The technical requirements around things like capacity would be part of a good requirements planning stage as well. And let's see. Oh, I forgot there was more to read here. This is probably all going to just say the same stuff. Okay. Planning for the application, defining the requirements to determine what it should do and its needs. An application that uses social media, for example, would require you to connect with a friend, or in some inventory programs, there is a search feature. So a search feature would be an example of a requirement. Defining the resources needed to build the project according to the requirements is also critical. For example, software may be developed to control a custom manufacturing machine. A device is required for the process. It's common for developers to produce a document known as a software requirement specification, or SRS. The next of these pre-development phases is design and prototyping. So it's necessary for developers to outline the details of the overall application, including its attributes such as interfaces for users, interfaces between systems, requirements for different networks, and instances of the databases that the application is going to rely on. And then the software requirement specification docs we just talked about would be converted into logical structures implemented in programming languages. Plans for operating, training, and maintaining the system will be drawn up to ensure developers know what they need to do through the lifecycle. Here are a few examples. Okay, good. So, example 1, an architecture specifies how codes are written, industry practices, the overall design, and any templates or boilerplates used within the program. Input is received and processed by the software through the user interface, which defines how the software interacts with customers. Defining a platform means choosing which media will run the software. It is not only about programming languages, but it's also about solving problems and performing tasks in an application. A communication method specifies how an application communicates with other assets, such as a central server or other instances of the application. Application security measures may include SSL traffic encryption, password protection, and user credentials storage. So you'd be considering all these things, I guess, during this design phase. A document called an Architecture Design Review, or ARD, is typically created by engineers and developers at this stage to ensure that all teams working in different areas are on the same page. In the case of an API endpoint, for example, front-end and back-end developers and teams handling authentication and authorization would be involved in that architecture design review process. Okay, good example. And then lastly, software development. So that's when it starts getting juicy. The code is actually getting written and an application is developed based on all the specifications and designs that you did in these earlier phases. Software developers appreciate instructions and explanations. Playbooks and guides for the application can be documented as part of the documentation process. Developers will use compilers, debuggers, and interpreters to adhere to coding guidelines established by an organization. A very effective initiative to promote secure coding would be incorporating code hygiene, code best practices, and security in playbooks. All right, and then the first question here, what phase focuses on determining the first idea for a prototype? So that's probably one of the top ones here. Yeah, okay, so requirements definition is about defining the prototype's ideas and getting all the necessary details. So let's see if it's requirements definition. This is like really lagging for some reason. So the hype and anticipation is just building in such a dramatic manner. All right. What stage is also known as the feasibility stage? So I think we learned that's the planning stage, right? Because I went on like my little rampage about it. Okay. So planning phase. I noticed the answer is 2 words. Let's see if this is right. Might be planning stage. Let's try that. Yeah. Okay. So planning stage. And then when do you outline the user interfaces and network requirements? So that was that third stage, which is called design and prototyping. All right. Okay. So that's task 3. Nothing too crazy here, just reading and trying to get up to speed on all these different important Concepts. Next is task 4, which is going to cover the other phases of the life cycle. SDLC phases part 2. The final phases focus on testing the application before release and then maintaining its healthy operability afterwards. So it's critical to test an application before making it available to users. I don't know why that made me laugh, but it really did. Okay, during the testing stage, developers will review their software using automated tooling like source code scanners. The project's goal is to meet the previously defined quality standards that we set up during the planning and requirement stages. Testing is an essential pillar in moving towards a more secure development lifecycle, right? Because you want to catch anything you can before it makes it to production where end users are interacting with it. And to introduce testing effectively in the SDLC, it has to go through its own software testing lifecycle phases. Sometimes there are dedicated teams as part of a testing function. For example, a QA team with the quality analysis engineers, testing engineers. And I've never gotten to work on a project with a QA team, so I don't know. I'm not very knowledgeable about that, but hopefully Lego learns more about it. And then the most notable phases when introducing testing are test case design and development, test environment setup, and test execution. Okay, so let me catch that again. The most notable phases for testing: test case design and development, test environment setup, and test execution. Test case design and development. With the test plan in place, testers begin writing and creating detailed test cases. In this phase, the QA team fleshes out the details of the structured tests they will run. So you want to achieve like as much as what's called test coverage as you can, and you write different test cases to basically try to test all the different components of your application, paths, way the application could interact, etc. So you want detailed different test cases. You don't just want to test one path. You want to catch your edge cases, everything like that. When conceptualizing test cases, the tester's goal should be validate functionality within the allotted time and scope you have for testing, especially the core functionalities. Test cases should be simple, well understood by any team member, and unique from other test cases. Test cases must be identifiable and repeatable, as developers will add new functionality to the product over time, requiring tests to run again. They can't change the test environment for future tests, especially when validating configurations. Test cases might also require maintenance or updates over time to validate both new and existing functionality. Once test cases are ready, a test team lead or peer can review them or check and update automated test scripts. And then usually your testing is automated and probably part of your CI/CD pipeline. Test environment setup. The test environment provides the setting where the actual testing occurs. Testers must access bug reporting capabilities in the application architecture to support the product. Once ready, testers establish the test environment's parameters, including the hardware, software, test data, frameworks, configurations, and the network. For example, most of a product's users might be on an Android device, use a specific version of a Chrome browser, and have a certain amount of processing power on their devices. So these are the types of parameters that you would then include when you're setting up the test environment. And you may have heard the joke about like testing in prod. You don't want to be testing new code in your production environment where your actual application runs. You want to have a separate test environment set up, and you want to have that test environment be as similar to the production environment as possible. And this is kind of like saying you want to be testing it in a way that's most similar to how your users actually interact with it. So the more you can have your test environment the same as your production environment, but just with test data instead of real customer data and stuff like that, the better. But sometimes it's cost prohibitive to have two fully formed environments. So a lot of times, especially in the cloud, your test environment might model the exact architecture of your production environment, but have smaller, cheaper resources, for example. So smaller server, smaller database, just like a cheaper kind of shadow version of your production environment. And then test execution. So in the test execution stage, testers execute all the test cases that we wrote and designed in the test case design phase. For example, QA engineers and automated scripts run several functional and non-functional tests. Testers will identify and report detailed bugs from test case execution and then log the system performance to compare to what the requirements are. Often testers retest the product as part of regression testing as developers make fixes to ensure new flaws don't make it into production. With all of these tests piling up in the test execution phase, it's essential to use test automation to achieve the test coverage and velocity you need. Developer velocity is a metric that helps us understand and estimate how much development our team can perform in a given time frame. All right. And then deployment is after we test it, we actually deploy the software. So after testing, the overall design for the software starts to come together and different modules or configurations are integrated into the primary source code. After this stage, the software is theoretically ready for market and provided to end users. Many companies automate the deployment phase using tools we will later see in the DevSecOps pathway. These tools focus on what you call software deployment tools or release management. The focus is on automating software rollouts so that the team can deploy new applications on all machines or just selected ones. There's a lot of different ways to deploy software. Sometimes you do like blue, green, or canary deployment, and you just deploy to a certain set of users at first, the changes to see how it goes. There's a whole world out there of ways you can deploy software. And let's see, and deploying new applications on all machines or just selected ones. This is particularly important if a new package requires actions to deploy correctly, for example, a reboot of the machine. So if you have to reboot your servers, for example, to deploy your update, you don't want to be probably rebooting every server at once, making the update to every server at once, because then your application is going to be offline. Popular software deployment tools are Netlify and Argo CD. So I think Netlify I've used before, Argo CD I've never used. And during the deployment phase, a new feature on the company's website can be released, or in case of mobile development, download a new application. Like the App Store, you go download a new version of the application on a smartphone. That's because they've deployed a new release. Furthermore, automating the deployment processes also allows the capability to roll back a deployment, making it easier to go back if there are unforeseen circumstances with the deployment. That's a huge benefit of CI/CD continuous deployment is the more often you're deploying, if you do have to roll back, you can roll back to a closer state rather than like all the way back to the beginning. And 7, operations and maintenance, always a challenge. Developers must now move into maintenance mode and begin practicing any activities required to handle issues that the end users might report as they start actually using the software. Furthermore, developers are responsible for implementing changes the software might need after deployment. In this phase, users discover bugs that weren't found during testing, for example, handling residual bugs that could not be patched before launch, or resolving new issues raised during user reports. So sometimes you maybe don't have the luxury of time to fix all the bugs that you know are there before you have to make a release. So you prioritize the bugs that absolutely have to be fixed. And then even after the software has been released, you still have a backlog of bugs you know you need to address. So that would be part of this phase here. And developers now focus more on stability and uptime than developer velocity. And the operations team now has a stake in developer velocity and their traditional role of maintaining uptime. When it comes to the specific part of operations in DevOps, this often means that so I think maybe they means operations team here. They enable self-service for developers to promote developer velocity where developers seek their solutions. Operations teams work closely with developers to provide on-demand access to secure, compliant tooling and environments. They standardize tooling and processes across the business. The best way to enable a sustainable self-service model and empower teams to work autonomously is by standardizing the tooling. Tools and techniques that are standardized and well documented enable organizational unity and greater collaboration. This reduces the friction developers and operations teams experience when sharing responsibilities. And then lastly, it says they, and I'm so sorry. I can't figure out, like, I think they is the operations team, but if I have that wrong, somebody tell me because I'm not quite understanding. But I guess I could be wrong, but I'm thinking this they means the operations team again. They are bringing extensible automation to traditional operations tasks. DevOps teams, so maybe it means DevOps teams. DevOps teams focus on empowering other teams through self-service and collaboration. Standard operations tasks like resolving incidents, updating systems, or scaling infrastructure still need to be addressed. When development and DevOps work closely together, teams automate through repeatable tasks and drive consistency across the organization. That's the dream. And DevOps teams can track and monitor metrics thanks to consistency and automation of tasks. For example, by automating the creation of your virtual machines in the cloud through Terraform, which Terraform is infrastructure as code. If you've done the intro to DevSecOps room that we talked about that a little bit. And you can log activity for virtual machines created and accessed. You can extend this further by creating alerts for how the service accounts and roles are used to develop infrastructure from a security and compliance point of view. As operations teams shift towards greater automation, X as code becomes the new normal. And I think the X stands in for things like infrastructure as code, configuration as code, et cetera. As example, I think this is supposed to say an example of this would be Vagrant or Ansible. The code controlling operation systems must be stored, versioned, secured, and maintained. All right, so that was task 4. Which phase focuses on handling issues or bugs reported by the end user? So that was operation and maintenance, I think. Yep. Why spell when we live in the future? So let's do that. Okay. Which phase involves releasing new versions of the software? So that was deployment, I think. And what phase ensures software meets the standards defined in the requirements phase? So that was testing. Let's see. I guess I could have just, if I had to scroll that far, I guess I could have just typed testing, but that's okay. So let's see. Testing. And that is task 4, which was completes the overview of the different SDLC phases. And I just want to scroll back up really quick because I did really like, maybe it was under here, because I did really like this graphic, the 7 phases of software development lifecycle. So I'm going to try to remember this, but this is like one of, beyond just the content, I also just like it because I like this glowing blue. It's like one of my favorite colors. Okay. All right. So that was task 4 done. And now I'm going to move on to task 5. Task 5 is called Keep Calm. So this links to an Atlassian post that's, I think, pretty well known, but it's about a framework called the Calms framework. And Calms, as explained in the linked Atlassian post, I'll link below in the video too, is a framework that assesses a company's ability to adopt DevOps processes. The acronym was coined by Jez Humble, co-author of the DevOps Handbook, which stands for Culture, Automation, Lean, Measurement, and Sharing. Can we just take a minute to say Jez Humble is an incredible name. I'm like so jealous that that is that person's name. So anyway, what's the point? Okay, so CALMS stands for Culture, Automation, Lean, Measurement, and Sharing. Culture, as we talked about in the intro to DevSecOps room, DevOps isn't simply a process or a different approach to development. It needs to be a culture change. There needs to be cultural buy-in. For any DevOps adoption to be successful, an organization will have to make a culture shift rather than slower full release approach of the waterfall model. Teams will have to adopt new strategies to break projects into smaller tasks that can be completed and then presented in a series of sprints. The culture shift is required for all employees, including not only the development teams, but also QA, product management, and operations. And if you're not familiar with the term sprints, so that's like an agile term. I mean, I think that's how the context I know it in. It's an agile term, and usually sprints are short, concentrated periods of work. So week-long sprints, 2-week-long sprints, and you're trying to hit a certain development milestone by the end of your sprint. So again, instead of like the waterfall methodology of developing the whole program and then releasing it, usually you have a 2-week sprint, and in a lot of organizations, your goal at the end of the sprint might be to release a new feature or something like that. All right, and then we have automation. Automation, which is the A in Calms. A large part of DevOps is the focus on automation. Since we are breaking projects into smaller components, it would be inefficient to then manually integrate these components into the final solution. Thus, it is better to spend some time creating automated processes that can ensure that new feature integrations can occur in a reliable and repeatable manner. This is usually started on the continuous delivery side of things for new teams, but as teams mature, it will also move to continuous integration. And automation is like one of my favorite topics. I think it's so fun. It feels so good when you think of something you could automate and then you automate it and then it works. Like that's one of my favorite things to do in software development. There's a famous like joke and expression that I'm totally guilty of it, which is like, why do in 5 minutes what you could take 10 hours to automate? That's very much me. Like, I love automating things. All right. Mature teams can also look to automate the configuration itself through tools such as configuration as code. This means that the configuration of the application itself is defined in code, which would alter build instructions depending on the environment that the application is built for. This streamlines the process of building production-ready code, and configuration parameters could be used to reduce the verbosity of errors, for example, or remove developer bypasses before code is built for the production environment. So you could use different variables to automate your build so that you're building the software differently for different environments. The L is lean. By implementing DevOps, we want to make sure that tasks are broken as small as possible. This allows teams to create initial versions of applications sooner. The common principle is that we are constantly improving our software, but it is more valuable to get a version of our application into the hands of the users earlier rather than having to wait years until the product is fully perfected You want to just get the product in the hands of the end users so they can start using it and you can start getting more real active feedback from the actual audience. We start with a lean first version that is constantly improved with time. Another term that's similar to lean first version that you hear sometimes is MVP, minimum viable product. And that's the same idea. As soon as you have something that you can release, just release it and then keep building, even with that first version out there, keep building, keep improving upon it. This method also allows our user base to provide feedback and a wish list of features for the application. So we can build our application with a lot more input from the users. The M stands for measurement. When implementing DevOps, it is important to have some sort of measure of effectiveness. These metrics are important since they will help us make small changes to our processes and ensure that we are constantly improving. In the next task, we will elaborate on how DevOps handles measurement and essential metrics to see constant improvement and monitoring. Last is sharing. In an effective DevOps pipeline, there is a shared responsibility for the overall application between all teams, including development and operations. Understanding that all team members are required to deliver the final solution and share in the responsibility to do so will result in a better product for users. And then for task 5, there's just this question, just testing our retention, I think. And the question is, what does CALMS stand for, the acronym? So the first was culture, right? Because we talked about DevOps is a cultural shift, not just a process you can put in place. A was automation. L was lean, and that idea of just getting the product in front of users as soon as possible. I think M was measurement, right? It's either measurement or monitoring. I think the M is measurement. And then S is sharing, like we can see on the screen here. All right, let's see if I got this right. Okay, so that's the CALMS framework. Whoop, whoop. We got it right. And the CALMS framework, CALMS stands for culture, automation, lean, measurement, and sharing. And if you want to really learn more about it, you can read the blog post as well. With that, on to task 6, which is about DevOps metrics. So this will be useful for some of like the measurement we just talked about. It is crucial to understand what metrics DevOps engineers gather before you can advise and introduce security. As seen in the Intro to DevSecOps room, gaining common ground to build perspective and empathy is crucial for buy-in and instilling security. So we want to understand the metrics that are really important to the DevSecOps engineers so we have empathy for what their priorities are and goals are. All right, so DevOps metrics. During the process of manually creating infrastructure, deployments are blocked. There may be too many errors in the live application, indicating that the security test automation needs to be improved or is taking too much computing power and time. Understanding how and where to find improvement requires metrics to measure your resources. Here are the essential metrics gathered by engineers and the questions it aims to answer. So I think these are the questions that we are hoping these metrics will help us answer. Mean time to production, or MTTP. What is the turnaround time for a newly committed source code? So when this new source code is committed to the repository, how long does it take for it to actually make it to production? Frequency of deployment. What is the frequency of deployment of releases? The average lead time. How long does it take to develop, build, test, and deploy a new feature? Speed of deployment. A new release is deployed into production. How long does it take? So the frequency is how often you're deploying the new features, and then speed is when you do deploy a new feature, how long does it take to get into production? And then deployment agility. You can measure deployment agility by combining deployment speed and frequency. Production failure rate. How often do failures occur in production? Hopefully not very often. And MTTR stands for mean time to recover. When a failure does occur in production, how long does it take to recover from that failure and have all systems go again? So you want MTTR to be short, to be a small window of time. MTTP, one critical DevOps metric to track is the mean time to production. MTTP is the length of time between when a code change is committed and when it is in a deployed state. A pre-release test, for instance, is passed when all code requirements have been met. Test automation and working in small batches are good ways to improve MTTP time. Developers can receive fast feedback on the code they commit by following these practices, identifying flaws, and fixing them as quickly as possible. So when you're making changes to the application and you're committing those changes to the source code, you want a lot of small commits rather than few big commits. Let's see. And then we have failure rate. When a code change goes into production, a certain percentage of code changes require hot fixes or other remediation measures. It does not measure failures caught during testing and fixes before the code is deployed. So if a failure happens in a testing environment or like a staging environment or something like that, it wouldn't contribute to your failure rate. The same practices that enable shorter MTTP times correlate with reducing change failure rates. All these practices make bugs much easier to identify and remediate, right? Because if you have a smaller commit, it's less of a needle in a haystack to figure out the source of your bug or your problem. And tracking and reporting failure rates are essential for ensuring new code releases meet security requirements. Deployment frequency, understanding how often new code is deployed into production is critical to DevOps success. Deployment frequency differs to MTTP as it measures when it's released into pre-production staging environment and reserves deployment to refer to code changes released into production. All right, let me read that again. Deployment frequency differs to MTTP, mean times to production, as it measures when it's released into a pre-production staging environment. So deployment frequency, the metric differs to MTTP when it's measuring a release into pre-production staging environment, and then reserves the term deployment to refer to code changes released into production. All right, this sentence is like scrambling me a little bit if I'm being honest, but I'm sure it will make sense as we keep going. Teams can deploy changes on demand and often many times in a day. The ability to deploy on demand requires a deployment pipeline that incorporates automated testing and feedback mechanisms, as mentioned in the previous tasks, minimizing the need for human interaction. So the idea is you have a CI/CD pipeline that you're using, and when your developer commits code, makes a commit, that triggers the pipeline automatically without a human having to do anything. And then the code goes through the pipeline and all those tests run automatically as part of going through the pipeline is what we're getting at here. And then MTTR, when a partial or total service interruption occurs, the mean time to recovery, or the MTTR, is measured. Keeping track of this metric is crucial. If a failure occurs, a fix must be deployed as soon as possible, or the changes that caused the failure must be rolled back. In most cases, this involves monitoring system health continuously and alerting operations in the event of a failure. You also want to be like backing up data, backing up configurations. The operations team have the necessary processes, tools, and permissions to resolve incidents. So that's part of how you could have a faster MTTR, is know that the relevant teams have good tooling in place and the necessary permissions that they're going to need to get in and solve the problem when a failure occurs. And then lastly, communicating risk. You can demonstrate improvement over time by measuring any of these metrics, and you'll have the evidence to support and get buy-in from the business and the teams. Risk means very different across teams, so different teams have different risks that they prioritize and care about. For DevSecOps engineers, risk means the likelihood of a vulnerability being exploited and its impact on your systems, whereas for a DevOps engineer, a significant risk would be a high rate of production failure. For example, by understanding other teams' definitions of risk and just really understanding what other teams care about, a DevSecOps engineer can find common ground and build a better perception of security risk for other teams. So it's all about that empathy that we learned about in the first room. What two metrics are used to measure deployment agility? Okay, so that was like deployment speed and, this is why I don't try and spell, and deployment frequency, except I wonder if I'm supposed to switch these because I noticed the input guide had the long word first. So hold on, let me try that. All right, let's try it like this. Nope, deployment frequency. Oh, so deployment speed and frequency. Let's see if that's right. Yeah, okay. Deployment speed and frequency. And remember, those are combined together to get the deployment agility. And then what is an essential rate for engineers in production environments to know if code meets security requirements? So that's the failure rate, I think. Okay. And then what is the measure for recovery time after a failure? So that's MTTR, mean time to recover, or recovery. I'm not sure. All right. So that is task 6. And then the last task to wrap up this room is task 7, production of the droids. So it looks like we have another static website to use here. I love the way TryHackMe has such good design here where it just opens so nice for you in the side panel. Now that we understand the principles of the software development lifecycle, it's time to put them to the test. Launch the static site attached to this task. You have been placed in control of a droid production factory. Oh my God, let me just tell you, I'm the least qualified person to manage a droid production factory, but I will give it my best. The Empire has provided you with a round of seed funding of $1 million. However, the Empire expects a great return of double the initial investment. So it's all about the funds. Using these funds, you are tasked with hiring developers and deciding how many sprints these developers will have to build droids. For this task phase, it is important to remember the mythical man month principle, also called Brooks' Law, that states adding human resources to a late software project will make it later. So be careful, as adding more developers might decrease the efficacy of your sprints. So it's not always a solution just to add more people. Once you have decided on the number of developers and sprints, it's time to allocate these sprints to the various SDLC phases. As you add sprints, pay careful attention to how this will affect your factory's effectiveness. Once you believe you have found the optimal split of sprints, there's nothing left to do but start the production machine. Oh, that's like so fun. Okay. While the challenge is to double the investment, with some smart thinking, you might be able to achieve even more than that. Think you have achieved a high score? Share it on Discord or LinkedIn. Oh, wow. Okay, so let's see what we're trying to do. So we've got $1 million. The cost of a developer per sprint is $3,000. And we want to figure out the optimal number of developers and the optimal number of sprints. I'll be honest, I don't. All right. So we probably want to think about dedicating sprints to each of these phases that we learned about. Let's go back to this diagram. So we've got, it'll be really small here, but that's okay. So we've got planning, defining requirements, designing and prototyping, software development, testing, deployment, operations and maintenance. And I think we're just focused maybe on getting up to deployment. We're in control of the production factory. Okay. So it's kind of hard. I think the hardest part is to figure out how many developers to have for a sprint. I guess we're just going to need to start experimenting. So let's start with a team of 5 developers, because I've been in the AWS rooms lately. We're talking about the 2 pizza teams where you have a smaller team that owns a product. And let's have a lot of sprints. The reason why I want to have a lot of sprints rather than just have a ton of developers is because we've been learning, right, the more small and modular the work is, the better. So maybe we'll just focus on having a lot of sprints. All right, so we can do, all right, so I have spent $150,000 because I have my 5 developers for 10 sprints. Let's add more. And our goal is to develop, let's add some more. How many sprints do I have? 40, 50. All right, and I still have $250,000. This is crazy. Okay. And where do I see the efficacy of my sprint? Oh, I see. So we'll choose the sprints here and then we allocate them to the phases on the next page. Okay, cool. So we're up to 50 sprints, which is quite a lot. If you had week-long sprints, that would be almost like that would pretty much be a year. So let's add a few more developers to use up the rest of our money. I wish I could split my developers into different teams. All right, so now I have 6 developers and I have 50 sprints. Let's take away 2 more sprints so that everyone can have a nice winter holiday. And let's see if that lets me afford 1 more developer. All right, let's do that. So now I still have $13,000. I don't know. We'll see. So I'm going to start with 7 developers and 47 sprints. I feel like I'm like in an interview having to explain my logic. All right, so now we can allocate the remaining sprints. So we have all the phases, and I still don't see where I can see the efficacy of my sprint. Game metrics, lower limit. Oh, so we can see these different metrics. Okay, cool. This is very creative. So for planning, we have 47 sprints. So let's see what happens if we start with 5 sprints. So let's do 2 months for planning. So let's do, in my head canon is that these are week-long sprints. So let's do 2 months for planning. Actually, let's do 6 months for 6. So actually, let's do a month and a half for planning. And then let's do another month for defining requirements. For design and prototyping, I'm already down to 37. For design and prototyping, let's do 5 sprints to start. For software development, let's do, you know what? I feel like I'm getting very waterfall-y here because I'm doing all this planning and design. now I'm like going to take a long time before I actually get to deployment. So let me make this shorter. Let's do that. So that's our beginning. Let's do that. Now we can start developing the software. So let's do a few sprints for initial development. Let's do, oh, and I forgot I can be seeing what's going on down here. All right, cool. And then let's do deployment. And then let's do 2 weeks for deployment, operation and maintenance. So maintenance, let's start with 5 here. Okay. And let's see what I have going on here. Here's my metrics, lower limits, rate of new bugs, upper limit. Okay, start game. So that's what I do when I'm ready to test. So we still have 24. So we still have 24 sprints, almost half of our sprints. So let's crank this back up to 6. Let's crank this back up. Well, let's do -1. Let's crank this back up to 5. That's going to be like our project kickoff. After we understand the requirements, we can do design and prototyping. Let's make this higher, do more testing, and then more deployment. I don't know. I don't really know if there's like a method to the madness here. But we haven't used all our sprints yet. So I'm going to add more requirement definition because I do think that's really very important. And where did we learn that the feasibility study is? So that's right here. Design and prototyping. Maybe we just need more of this to be the actual software development. So, and we're left with 5. Okay. All right, so now let's see how these metrics are looking. So our upper limit of rate of new bugs is 5%. I feel like in the context of this game, that's pretty good. Our droid production rate is 100 to 153. Our percentage of defective droids is low. So it seems like our quality here is pretty good. And our production cost is expensive. And our upsell percentage is pretty low, I would say. So I don't know. I'm supposed to be doing math here, but I'm certainly not going to. So let's see maybe if we take 5 away here, what happens. So if we take away 5, our production rate is less. So let's start the game and let's see what happens. All right, so we had 2 defective droids out of 101. That's pretty good, I would say. We did run a profit, so that's good as well. So let's see what happens in February. Defective again, money out. So we made money again. And our goal, I think, is to get to $1 million by the end of the year. So it looks like we're on track for that. Funds at start of the month. Yep. So we're doing okay, you guys. We're doing really good. Look at this. So now we're already up to $777,000, and it's only March. I feel like that's pretty darn good. We're on track here. And then I wonder if there's gonna be like a curveball coming in the factory is gonna burn down or something. Uh-oh. So what happened here? Now we lost money. How did we do that? 183. So we had to spend more money here for some reason. I don't know why. Let's see what happens next. And I don't see, and I still don't see. All right. So now we made money again. That's good. Okay. We just broke $1 million. That's good. That's good. I'm so excited. I wish this was real. I wish this was my real factory. And okay, we're really killing it now. August. Let's see if we can get to 2 million. I think we just did, right? This is 2 million. What if I'm counting my decimals wrong? But I don't think I am. Okay. And then October, November, December. How'd we do? All right, awesome. So we did quite good. We made $2.5 million. And I wish I could can I go back and see my factory, what my optimal factory rates were? I guess not. Anyway, good job us. And here is the flag that we can paste to finish the room. I'm like actually very excited. I didn't think that was going to go so well. So that was a lot of fun, that little game. I enjoyed that a lot, even though I clearly had no idea what I was doing, if you could tell as I floundered. So the next room in this DevSecOps learning path is SDLC. So that's the Secure Software Development Lifecycle. Thank you very much for watching the walkthrough of this room. I know these first introductory rooms are just a lot of reading, so I'm looking forward to getting farther along in the learning path where we'll actually be doing some hands-on hacking type stuff. I'll be jumping into this next room soon, and thank you so much for watching.